Good day everyone, I am Zesma Elginton, and today we are diving into the heart of trigonometry, specifically the unit of circle. So our focus is on our three learning objectives. The first one is use correct mathematical notation and terminology. The second is perfectly define and draw a unit circle and identify the coordinates of trigonometric points of special angle. Correctly identify the six trigonometric or circular functions and their value limits based on this unit. Let's begin with our first objective, using correct mathematical notation and terminology. Mathematical notation and terminology are essential for understanding and communicating ideas in the unit circle. Here are some key notations and terminologies. Angle representation. We use degrees and radians to measure angles. Example, 30 degrees equals pi over 6 radians. Trigonometric functions. These functions relate angles to the coordinates of points in the unit circle, providing a way to understand and calculate trigonometric values. This includes sine, cosine, tangent, cosecant, secant, cotangent. Example, sine of pi over 3 equals root 3 over 2 and cosine pi over 3 equals 1 half. This tells us that for an angle of pi over 3 radians, the corresponding point on the unit circle has coordinates 1 half root 3 over 2. Coordinate notation. These coordinates represent the cosine, x coordinates, and the y coordinates of the angle. Example, the point root 2 over 2 and root 2 over 2 in the unit circle corresponds to an angle of pi over 4 radians. Here, cosine pi over 4 equals root 2 over 2 and sine pi over 4 equals root 2 over 2. Greek letters. Greek symbols such as theta and alpha commonly denotes angles. And now let us proceed to our objective number 2, which is define and draw a unit circle. Let's begin making our unit circle. So the first thing that we need to do is we're going to draw a coordinate plane. And here. So a unit circle is just a circle with a radius of 1 and the coordinate plane with a center at the origin. So the center is here. The radius is here, which is 1. So in a unit circle, there are 4 quadrants. So this one will be quadrant 1. This will be quadrant 2. This will be quadrant 3. And this will be quadrant 4. So every angle on the unit circle has equivalent degrees, radians, x and y coordinates. So let us first start with the degrees. Degrees. So we are going to start here in quadrant 1. So the first angle is here, which has a equivalent of 30 degrees. 30 degrees. And the second one is here, which has the equivalent of 45 degrees. And the third one is here, which has equivalent of 60 degrees. So this angle is 90 degrees. So these angles that belongs to quadrant 1 is called special angles. So we're done in quadrant 1, and now let us proceed in the next quadrant, which is quadrant 2 here. So since this angle is the same as this, we are going to add the 90 degrees plus 30 degrees. So this will be 120 degrees and so on and so forth. So let's continue this one. Since this angles is the same as this will be 90 plus 45, which is 135 degrees, and the next angle is this. Since this angles is the same as this will be going to add 90 plus 60 degrees. This will be 150 degrees. Since this angles is the same as this, we're going to add 90 plus 90, which is 180 degrees. Since we are done in quadrant 2, let us now proceed in the quadrant 3. So this angle is here. So since this angles is same as this, we're going to add 180 plus 30. So this will be 210 degrees. And the next one is here. Since this angle and this is the same, we're going to add 180 plus 45. So this will be 225 degrees. Let's go with the third angle in that quadrant 3. So since this angles is the same as this, we're going to add 180 plus 60. This will be 240 degrees. So the equivalent of this angle would be 270 because we are going to add 180 plus 90. So 270 degrees. So we are done in the quadrant 3, and now let's proceed to the quadrant 4. So this angle is same process. We're going to add 270 plus 30 because this angle is the same as this. So 270 plus 30 is 300 degrees. And we're going to add 270 plus 45 because this angle is the same as this. So this will become 315. And with the last angle here, this will become 330 because we're going to add 270 plus 6. This one will be 360 degrees because 270 plus 90 equals 360 degrees. Since we are done with the degrees, we're going to proceed to the radians. Radians. In order for us to get the radians of 30 degrees, we are going to use this one. 30 degrees over 1 multiplied by pi over 180 degrees. So let's going to solve it. Let's going to crush it out. This one, and this will be 3 over 1 times pi over. So we are going to find numbers that if we multiply, the answer will be 18. So this will be 6 times 3. So 6 times 3 equals 18. So we are going to crush out 3. So the remaining will be pi over. So 1 times 6 is 6. So this will be the radians of 30 degrees. Pi over 6. The same process to get the radians of 45 degrees. So 45 degrees over 1 times pi over 180 degrees. Since there is no zero here, we're not going to crush it out. So this will be remains, and it will be 45 over 1 times pi. So we're going to find numbers that will be multiplied. The answer will be 180. So 45 times 4 equals 180. So this will be crushed out. So the remaining will be pi over 1 times 4 is 4. So this is the radians of 45 degrees. Pi over 4. The process will be repeated. This will be 60 degrees. Times pi over 180. So degrees will crush out the 0. So equals 6 1 times pi over, so we have to find numbers that will be multiplied. The answer will be 18. So 6 times 3. So we're going to crush out 6, and the remaining will say pi 1 times 3 is 3. So this is the radians of 60 degrees. Pi over 3. So the same process with the following degrees. So the radians of 90 degrees will be half pi. So over radians of 120 degrees will be 2/3 pi. 135 degrees will be 3/4 pi. Radians of 150 degrees will be 5/6 pi. The radians of 180 degrees will be pi. The radians of 210 degrees will be 7/6 pi. The radians of 225 degrees will be 5/4 pi. The radians of 240 degrees will be 4/3 pi. The radians of 270 degrees will be 3/2 pi. The radians of 300 degrees will be 5/3 pi. 5 pi. The radians of 315 degrees will be 7 pi over 7/4 pi. The radians of 330 degrees will be 11/6 pi. 11/6 pi. While the radians of 360 degrees will be 2 pi. Since we are done with the radians, let us now proceed to its x and y coordinate. First, we must put in our minds that sine and cosine are from SOHCAHTOA. Sine means the length of the leg opposite the angle over the length of the hypotenuse. While the cosine means the leg of the adjacent to the angle over the length of the hypotenuse. What we must also understand is that every point in this circle has an x-coordinate equal to cosine theta and y-coordinate equal to sine theta. Take 0 as an example. So there's no triangle, but since the radius of the circle is 1, we know that the cosine of 0 is 1 because the x-coordinate of this point is 1, while the sine of 0 must be 0 because the y-coordinate of this point is 0. So let us proceed with the pi over 6. So let us base on this special triangle. This would be 60 and this would be 30 and this 90. Root 3 and the opposite is 1 and the hypotenuse is 2. In order for us to get the x-coordinate or the cosine of this, we're going to locate, as I said earlier, cosine theta is adjacent over hypotenuse. So the adjacent of this is root 3 over the hypotenuse. And to get the y-coordinate or the sine theta, I also said earlier, sine theta is opposite over hypotenuse. So the opposite here is 1 and the hypotenuse is 2. And this is the x and y coordinate of pi over 6. For quarter pi, we have this other special triangle, and both the sine and cosine of 45 are root 2 over 2. Let us draw the 45, 90 triangle. This would be 45, 90. So the hypotenuse of this is root 2 and the other side is 2 and 2. So the x-coordinate of quarter pi is root 2 over 2 and its y-coordinate is root 2 over 2. So as for pi over 3, we have the same values as pi over 6. Since it's the same triangle, just looking at the other angle but reverse. So the only difference is the x-coordinate of pi over 3 is 1/2 and its y-coordinate is root 3 over 2. So at half pi, this point has the coordinates 0, 1. Since its x-coordinate is 0 and its y-coordinate is 1. And we must also remember that in quadrant 1, both x and y coordinate is both positive. And that wraps up for the quadrant 1. And now, so let us proceed in the quadrant 2. So in quadrant 2, both angles have the same values with the point in quadrant 1. The only difference is that x-coordinate of the quadrant 2 is negative. So negative and the y-axis is positive. So 5, 6 pi is the same as pi over 6. X coordinate is negative, so let's write it down. Negative root 3 over 2, and its y coordinate is still positive. Same in 3 pi over 4, negative 2 over 2 root 2 over 2. In 2 pi over 3, the same as this, negative 1 half 3 over 2. This point, x coordinate of this is negative 1, and the y coordinate is positive 0. So let us now proceed in the quadrant 3. 7 pi halves the same as point in pi over 7 pi over 6. The only difference is that x and the y coordinate is both negative. So let us write it down. So negative root 3 over 2, and its y coordinate is 1 over 2. So in pi over 4, it's the same with this one. So negative 2 over 2 over 2 over 2. Same as 4 pi over 3. This would be negative 1 over 2 and negative 3 over 2. At 3 halves pi, we get 0 and negative 1. 0 and negative 1. Also, in quadrant 4, the x coordinate is positive and the y coordinate is negative. 5 pi over 3 is the same with this one. So positive 1 over 2 and negative 3 root 3 over 2. 7 pi over 4, it is the same as this, so it would be positive root 2 over 2 and negative root 2 over 2. In 11 pi over 6, it would be positive 3 over 2 negative 1 over 2. And that wraps up all the points in the unit circle. And now let's move on to our third and last objective, which is correctly identify the 6 trigonometric functions and their value limits based on the unit circle. So the 6 trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. Let us go first with sine. The sine of an angle in a right triangle is the ratio of the length of the side opposite to the angle to the length of the hypotenuse. So example, in a right triangle with an angle of 30 degrees, the sine of 30 degrees is 1/2. So you just simply locate the Y coordinate or the sine of that angle. Let's proceed with the second trigonometric function, cosine. So the cosine of an angle in the right triangle is the ratio of the length of the side adjacent to the angle to the length of the hypotenuse. So example, in this same triangle, the cosine of 30 degrees is root 3 over 2. You just simply locate the x-coordinate of that angle. The third trigonometric function, tangent. The tangent of an angle in a right triangle is the ratio of the length of the side opposite to the angle to the length of the side adjacent to the angle. Example, the tangent of 30 degrees is 1 over root 3. The fourth trigonometric function, cosecant. The cosecant of an angle is reciprocal to the sine of that angle. Example, the cosecant of 30 degrees equals 1 over the sine of 30 degrees equals 2. The fifth trigonometric function, secant. The secant of an angle is the reciprocal of the cosine of that angle. Example, secant of 30 degrees equals 1 and the cosine of 30 degrees is 2 over root 3. And the last trigonometric function is cotangent. Cotangent of an angle is the reciprocal of the tangent of that angle. Example, the cotangent of 30 degrees equals 1 and the tangent of 30 degrees is root 3. And that's all. Thank you for watching.